graph these as 1. Remember what we were doing there? Very good. We were covering and solving. By doing that, we were identifying where the... Man, you are so good this morning. You're 5. Very proud. Stop hanging out with Raylan. You'd be even better. Joke, because I know Raylan. That's fine. But as you go through the intercept stuff, it makes life a lot quicker with these types of graphs. So when we did this the other day, I would say, hey, just draw a graph. And we're doing one at a time. When I cover and solve the first one, if I go for my x-intercept, that's when y is equal to 0. That gives me an x-intercept at 2/3. You okay with that? So if this is 1, is it 2/3 about here-ish? It's okay that it's ish. We're just doing a simple idea of it. All right. Now I do the other cover and solve. Where's my y-intercept? -2. When you were solving inequalities in the past, you had to like flip signs and do all that stuff to get the y values or x values and whatnot. Do you have to do that when you're covering solving for intercepts? No, not at all. You treat it like you would an equality. The inequality portion is going to be the shading. We don't have to worry about that. So that does tend to people ask about that pretty regularly. I'm surprised you're getting it early, I guess. People are mopey. Why are you guys all mopey today? I was here all night with parents and stuff, so you guys, we need to like walk around or something, like wake up. Let's go left. Come on, let's go walk left. Let's go. Y-intercept. -2. Good. So between those two dots is either a dotted or a solid line to connect them. Why is it solid? Yeah, whatever the thing, this thing right here, yes. That line right there, correct. Did this one go through the origin? No. So I'm going to use the origin as my test point, just like we did about a week or so. When I test that, what is 3 times 0? 0. What is 0 minus 0? It's not 5. I mean, I get it. We can, if we have to use the calculator, we can use the calculator, but it's not. So, but 0 minus 0, in case if you take nothing from nothing, you're left with nothing. So that's okay, and it's nothing less than 2. Yeah. So it is true. So I'm just going to do this. Remember, I'm just putting it in a couple shaded regions, a couple lines like that, so it doesn't overwhelm the graph. All right. And I do the exact same thing with our next one. Here's my x-intercept now. At 1. Good. If you do happen to have 2 colors or a pen and a pencil, it is kind of nice to be able to do that. If not, it's not the end of the world because you'll still get the shaded area. So it's at 1. And then my y is at 2. Again, this one is going to be a solid line because it's got an equal part to it. And what did this not go through? 0. It didn't go through the origin. So what's 2 times 0? What's 0 plus 0? 0. Is 0 smaller than 2? Yes. So again, it is true here. So our region that it works will be any points within this value. Okay. That's what we're looking for today. That's what we're doing. We're basically just doubling our workload from when we did this last time. Instead of just putting 1 on a graph, we're putting 2 on a graph. We might even put 3 or 4 on. No, I know. It's anticipation of the craziness is palpable. You guys can do it. Okay? Like, not bad, right? Cover and solve. Cover and solve. It's the nicest, easiest way to graph these things. Actually, I think we just did the two. Ah, no, we'll be fine. Now, I wanted to make sure that I showed you, sometimes they'll give you a problem that is still in standard, or not standard, excuse me, slope intercept form. But, you don't need graph paper. I don't want you to use graph paper. I want you to visualize it. I want you to scale it. I want you to give it a shot. I want you to try and make your own space. Sir. Slope intercept. White slope would be the y minus y sub 1. It's prior to getting the slope intercept. So if you have slope intercept, can you graph it out a slope intercept if you want? Absolutely. Absolutely. Or can you put it in standard form if you really want it? Sure. I mean, it doesn't matter. So, but if I go back to the top one, do your covers and solves. X-intercept at 3, y-intercept at -3/2. It looks like that. Connect the dots. Solid or dotted? Solid as a rock. That's what feels good. No, you don't know that song. Man. Did it go through the origin? No. What is 0 minus 0? A big whopping 0. You are correct. So, cover the truth. Shade towards the origin. Okay? Not bad. Go to the next one. If you have a pen or a different color, change it out. If not, no big deal. This one's in slope intercept form. So graph it out of slope intercept form. You've already started marking off tick marks, so might as well continue on with what you were using. We have a y-intercept of -4. And now I have a slope of 3. Up 3 over 1. Up 3 over 1. Up 3 over 1. And I'm just using my pencil to count the marks up. And I'm trying to keep them somewhat sanely spaced. Remember, guys, it does not need to be perfect. You're getting a rough sketch visual representation. Okay? For this line, or inequality, do I solid it or dot it? I dot it, correct. The reason I dot it is because it's just a greater than. Okay? If you did connect those completely with a solid line, just put a little arrow saying dot it, and I'm cool with that. Because you fixed your mistake, and that's how you learn. And then lastly, what's 3 times 0? 0. 0 minus 4 is, bless you, -4, and then is 0 bigger than -4? Yes. So again, it's shading towards the truth. So you've got your little overlap area in there, which basically means any ordered pair you choose that's in the double shaded area is a solution for both of the inequalities. So if I chose -5 and +5 and put that in for x and y, I'll get a true statement. Any value that's in there. Yes, sir.
We do this with regular formulas if we feel
For well, here's the problem: when you get to those, you're not sure exactly what happens with those halvesies. Or remember how we had those really crummy decimals and stuff? So if I throw algebra stuff at you, it's probably going to be kind of crummy. When we get to our shaded boundary regions, we will be doing the intersection of some of these, and we'll have to do that algebraically to find that ordered pair. And that's just, you're just a day ahead of me. So there'll be a little bit of a mixture of both of them. Okay? And it'll be pretty quick when you start seeing it. Yes, sir. What? Where those two lines intersect, you mean? Well, remember what's happening here. You've got one line that's not technically there, and one line that is, because of the inequality. So if I had chose like where these two hit, it wouldn't technically work because it should be like, it's like an open dot as it goes through that spot and solid on the other. It's kind of like testing the point that you are using to start. You always pick something that's not on the line to see this, because if you're on that line, you're on the division spot of the half plane. Remember how we talk about half plane? So that's why we don't choose the point on it. I don't know why I left this graphic. Bless you. All right. Let's talk about boundaries. All right. So I have x is greater than or equal to 0, y is greater than or equal to 0, and 4x plus 3y is less than or equal to 24. Where on the graph is x greater than 0 and y is greater than or equal to 0? Correct. That's quadrant 1, isn't it? Are we okay with that? Remember, and I'll redraw this twice. When you're talking about the idea that x is greater than or equal to 0, it's all the numbers going from 0 this way, including down here. When I say y is greater than or equal to 0, I'm looking at all the numbers that are going up from here. From these two, I'm going to use this term called a constraint. It's a restriction that they're putting upon you. From those first two constraints, as reading it, it tells you that no matter what, you're only going to be looking for the overlap that occurs within the first quadrant. So it's kind of a little bit of a shortcut. As we start getting into, if you ever see x is greater than or equal to 0, y is greater than or equal to 0, you know that it's a quadrant 1 only problem. So all you have to draw then is quadrant 1, because this direction is all values of x that are greater than or equal to 0, and this direction is all values of y greater than or equal to 0. That's how I know that it's going to be a quadrant 1 problem. This will come in, this little shortcut trick will come in really handy here over the course of the next week or so. Reason why I say that is because when we get into our word problems, you're not going to have negative values. We're not looking for negative flower baskets or negative amount of cookies being sold or things like that. Cover and solve. Where's your x-intercept? 6. Where's your y-intercept? 8. So if I say this is 6, this would be at 6, 0. And this would be at 0, 8. Everybody okay with doing that? Connect the dots. La, 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 la. Did this one go through the origin? No. So what's 0 plus 0? 0. Is it smaller than 24? Yeah. So what we've done here is we've bounded a region. We've bounded a region in the graph that we can find the endpoints of it. I know 2 of the endpoints because of the x-intercepts. 6, 0 for the x-intercept. 0, 8 for the y-intercept. What's the other endpoint? 0, 0. What'll happen over the course, I don't know if we'll get to it today, but into tomorrow, we're going to be doing and finding the actual order, the actual ordered pairs where bounded regions are going to take place, and we're going to use those ordered pairs to figure out whether they are a maximum or a minimum value for some specific, what's called objective function. And as we get into those, it'll be given to you and you'll be working through it. Eventually next week, you'll be coming up with your own objective function, as like your objective is to sell the most seats for this price and seats for this price, and you want to maximize profit, that kind of thing. This is the idea of what we're heading towards. But again, not too terrible, is it? Must have been a nice person last year. What's that? Yes, sir. This one is just an x is greater than or equal to 0. So if it just tells you that x is greater than or equal to 0, what two quadrants will this occur? 1 and 4, very good. Remember, quadrants go 1, 2, 3, and 4 counterclockwise. Just a reminder, see if you guys remember this. When you're on your quadrants, what's positive, what's negative here in the first quadrant? Positive, positive, very good. Bless you, what's here?
Negative.
Negative, positive, what's here? And what's here? Okay, so just a little FYI, this is our x and our y value, x and our y value, x and y, x and y. What comes first in the alphabet, sine or cosine? Cosine. So eventually, little foreshadowing of things to come. Cosine, sine, cosine, sine, cosine, sine, cosine, sine. So for fun, take your calculator out. It's just fun. First thing what we'll do real quick is let's make sure that we are in degree mode. Because you guys don't know what, I mean, Judkins told you about have a radical day, but we don't know how to do that yet. Yes. Anyway, if you hit the button that says mode, then highlight where it says degree. Okay. You hit the button, I don't have a calculator out here, but you hit the button that says mode, highlight the thing that says degree. And what I want you to do is let's do cosine of 45. Positive or negative? Positive, okay? What's the sine of 45? Same number in there. Okay. Okay. Now, let's do the cosine of 120. Negative. Do the sine of 120. Do the cosine of, what would that be? 210. And do the sine of 210. Well, it's negative, right? Do the cosine of 300. Oops. And do the sine of 300. Good stuff. So if I start here at 0 and I go all the way around a circle, how many degrees do I go? 360. If I go halfway, where am I at? Okay, if I go half of that, where am I at? And this would be 270. This is why mathematics later on. When Miss Yule is working with you guys on trig, you'll at least have something in the back of your mind going. So basically I'm just doing this to help you guys out, to help her out later on as she gets going. Yes, ma'am. It's no big deal. To be honest with you, you won't be hitting, you won't be using any trig functions first semester at all. Second semester we do a little bit of trig. The first trig that we do is right triangle trig, which you'll be using things in degree mode. Okay. If you're in physics, you might do a little bit of trig before that, but it should be all. I think it should be in degrees still if you're in physics with that. If not, they would show you how to change it to radians and all that. If you get stuck on something off, but I just wanted to show you that the relationship between x and y, cosine and sine, also goes back and forth with trig functions. So little. Anyway, back to what we're doing. So you guys are okay that if I just draw it like this, because we know it's got to go this direction. I know I'm looking at just those two quadrants. I'm not worried about the rest of it. And now I just graph my two pieces. First one is 2x minus 1 up to over 1. Solid or dotted to connect those? Excuse me. Yep, very good. I don't have to draw my line going back the other way because it's stopped at a boundary there. Did it go through the origin? No. So is 0 bigger than -1? Yes. So it is bound within this region here. Okay. Yeah. It's weird because remember your x equals a number, it's always a vertical line. So if it's vertical at 0, which direction is it bigger than 0? That way. That's why. Does that make sense? It's weird because you're thinking, oh, x is go left and right, but yes, numbers that are bigger than 0 will track to the right as you're counting horizontally, but it's technically it's a vertical shade region, excuse me, abbreviating words. And then next one, start at +3, slope of 2. 1, 2, 3. They are parallel, very good. And then again, it didn't go through the origin. So is 0 bigger than 3? No, that's false downward. So really the only true overlap would be in here. Okay. Sometimes you'll have these bound where they make really cool pictures where they're opposite directions. You have like you can create a rectangle. You might create different shapes and things. It's kind of cool how some of these how they wind up playing out. But bless you. But as we get going into it, it's not set up to be horribly scary, bad, evil math stuff. At least we hope not. What section is this? 3? Way too many PDF. So let's do this. Let's do Let's do 36 and 37. And then I want to do some group ones just to make sure that we'll have a bunch of those coming up. 42. Eight, 49, and 50. Yeah, that's good. All right, I'll pull this up here in a second. I'll rewrite it down. I'm trying to mix them together and not get you pretty crazy ones. So this is section. Do not use graph paper. Okay.